Algebra 2, Rate of Change and Slope, Section 2.3. Today's objectives: find the rate of change, determine the slope of a line. That's it. Today's vocabulary: rate of change and slope. They're actually the same thing. Rate of change. The rate of change is the ratio that compares how much one quantity changes on average relative to the change in another quantity. Okay, let's just look at the equation. So rate of change is the change in y divided by the change of x, or it's delta y over delta x. Here we need to make sure that we keep in mind that delta y is either equal to, no, it is y2 minus y1, and delta x is equal to x2 minus x1. All right, my face is in the way again, so let's go ahead and get rid of that one. The table shows the temperature of a solution after it has been removed from a heat source. Find the rate of change in the temperature for a solution. So in this case, we just need to take two different points here and calculate. So what I'm going to do is I'm going to go ahead and take the second two. I'm going to take 3 and 143.7, and I'm also going to take 6 and 137.7. Now let's use our rate of change. So that was the change in y, so I'm going to do my 137.7. I'm going to subtract from that 143.7, and then we'll divide that by 6 minus 3. All right, so if we do this math, we're going to find out that this ends up just becoming a -6 over 3, or just a -2. So our rate of change in this case would be a -2. Now, I don't think that's going to be the case the entire time, but it works in this case, because right away I can see that these two values aren't going to give me that same value, because one has a 0, one has a 7, so we're going to get some sort of decimal number. But that's okay. It's just going to be an average rate of change. And once again, these two numbers won't give me that same nice little number of a 2 either. But we're just calculating it. These two worked. Move on ahead. All right, so here's another example. Here I can definitely tell that it's not a nice linear thing, but whatever, okay. Refer to the graph. Find the average rate of change from the percent of total music sales for both CDs and downloads from 2001 to 2008. Compare the rates. All right, so what's nice here is they give us two different data points. They give us this 89.2 and this 2%, and that looks like it was about 2001. Then they also give us this 77.8% and this 12.8%, and that was definitely in 2008. So once again, it's just a change in y's over change in x's, though in this problem we have two different things to calculate. We have CDs and we have downloads. So let's do this. So CDs, we're going to have a 77.8 minus an 89.2 all over, well, I'm going to go ahead and do a 2008 minus 2001. And then also for downloads, we're going to get a 12.8 minus 0.2 all over 2008 minus 2001. Okay. Well, the denominators I can easily do. This will just give me a 7. This will just give me a 7. For the CDs, I can subtract that. That's going to give me a 12.6. And I should probably use my calculator for the other one. So that's going to be 77.8 minus 89.2, which gives me a negative 11.4. Now we just need to divide those. So we have decimals and fractions. This is why I'm kind of dividing those. If I do a negative 11.4 divided by 7, I end up getting, this is a negative 1.63% change over those 7 years. And if I take my 12.6 and divide that by 7, I end up getting a positive 1.8% increase of rate of change. So this will be for our CDs. And this would be for our downloads. I imagine now both of those are down because people prefer to stream rather than actually buy. But, you know, books get old. Okay, slope. The slope of a line is the ratio of change in the y-coordinate corresponding to the change in the x-coordinate. Let's keep in mind here for a second that we had this average rate of change. I'm just write rate of change was equal to a delta y over delta x. And I had said that delta y is equal to y2 minus y1. And delta x was equal to x2 minus x1. So in this case, well, first off, I can put my face back on. So in this case, we can see here that the average rate of change is actually the slope. Because for our slope, we have m, which is the variable we use for this, equals y2 minus y1 divided by x2 minus x1. Example 3. Find the slope of the line that passes through each pair of points. All right, so I'm going to go ahead and write down my slope equation because until I get this thing memorized, I should probably write it down several times because it helps me to memorize it. M is equal to y2 minus y1 over x2 minus x1. Okay, let's do A. And if it helps, this is x1, y1, x2, y2. So we're going to get a 5 minus a negative 3. We need to do the double negative there. There is 1 for that, and then there is another one in the actual formula. And then divided by a 3 minus a 1. And I really should be writing m equals. I could have done it on the other side, but I'm not a fan. So this ends up becoming, well, that becomes a 5 plus 3, so we get an 8 over 2, or that our m is simply just equal to a 4. For B, we got slightly larger numbers. We're going to get m is equal to negative 9 minus 11 all over 24 minus a negative 8. All right, negative 9 minus 11, they're both negative, so we're actually going to add them together, but keep the signs. We're going to get a negative 20 all over. Okay, this is going to be a 24 plus 8, or a 32. All right. Well, we're not done there. We need to simplify. 20 and 32 can both be divided by 4. We're in Algebra 2 here, folks. We need to make sure that we reduce our fractions. So we're going to get m is equal to negative, yes, I'm writing it on the side, 5 over 8. There we go. So yeah, be sure to reduce your fractions, because even though it's kind of right, it's still kind of wrong if you don't. All right, our last example here, we're going to find the slope of a line given a graph. So the trick here is we need to kind of zoom in for a moment, and we need to try to find where our graph crosses nicely at those little checker grids. And I see one right here, and that is at, let's see, +1, comma, +1. Okay, that was nice. And then it looks like there's another one down here, and that one's going to be at 0 in the x, comma, let's see, 1, 2, 3, -3. All right, so we can use our equation, but let's go ahead and use our rise over our run. So first, I'm going to be rising 1, 2, 3, 4, and then we're going to be running 1. So our slope is actually m is equal to change in y, so we're going to be going up by 4 divided by the change in the x, which is just a 1, or that our slope is just equal to a 4. But let's prove it with math. Yay, everyone's favorite. Okay, here we go. So m is equal to y2 minus y1 over x2 minus x1. Or we get that our slope is equal to, well, our second dot is the pink one, so it's going to be a 1 minus, and then we get a -3. Okay, not bad. And then a 1 minus a 0. Well, it's looking like we might get that same answer. So that's double negative, so we get a plus. So 1 plus 3, or we get a 4 over 1, or that our slope is just equal to a 4. All right, so there we had two different ways to getting the answer. We followed the line. We went up by 4 and over by 1, and we also used the formula. See, I think that was the last one. Yeah, that's the last one. So there we go, folks. It was a short one. This is only 13 minutes long.